Welcome back to Class with Code at CWM University, where we will learn how to teach students how to convert between fractions, decimals, and percents in a way that builds understanding, not just memorization. The most important things to emphasize with your students when you're teaching this is equivalent fraction, decimals, and percents are just a different way to write the same number. Also, remind the students to simplify their fractions each time, and you always want to keep a place value chart nearby so the students know what place values are after the decimal, the tenths, the hundreds, the thousands. Okay, we're going to start off by looking at our place value chart, the tenths, the hundreds, the thousands. That's what we're going to be working with, writing our decimals. And we're going to count the grid to see how many are filled in. So we counted, it's going to be 25 of them. So there's going to be 25 out of the 100 squares that are there. So we want to write down our decimal first, which is going to be 25 hundredths. And then since we know how to write 25 hundredths, it's going to be two numbers after decimal, then we're going to write our percent. Percents are out of 100. So we know that we have 25 filled in, so we have 25%. So we're going to write that down. And then after we write our decimal, write our percent, then we're going to move on to the fraction. Now to find the fraction, we have to see how many are shaded in out of the 100. Because we know we're going to use 100 as our denominator. So we have 25 shaded in, so 25 is our numerator. And then 100 is going to be our denominator. Now we know that 25 hundredths is not simplified. So I want to see if I can divide the numerator into the denominator. So can 25 go into 100? Yes. I can count by 25s to get to 100. So I'm going to divide the numerator and denominator by 25. Once I do that, I have 25 divided by 25, which is 1. And then how many 25s are in the 100? There's 4 quarters and a dollar, so there's 4. So that leaves me with a fraction of 1/4. Now I'm going to write my therefore statement to show that all of these are equivalent. So 1/4 equals 25 hundredths. I'm going to write that in decimal form, which is also equal to 25%. You want the students to write the therefore statements so they know that they're all equivalent and they start connecting 1/4, 25 hundredths, and 25% as all being equal. Now we're gonna move on to the next one. We still have to count the ones that are shaded. When it's a whole line with 10 of them shaded, I ask students count by 10. So 10, 20, 30, 40, 50, then count what's left over, which was 8. So 50 plus the 8 is 58. So they have 58 hundredths, 58 out of 100. So we're gonna write that down. And then we know that our percents are out of 100. So how many do we have out of 100? We have 58. So our percent is going to be 58. That's why this 100 grid is very helpful to the students when they're writing a decimal and when they're writing a percent and when they're trying to figure out the fraction. So I know that I have 58 of them shaded in as my numerator. And then I'm going to have 100 as my denominator. So make sure you're using those words when you're talking to your students. You want to use numerator. You want to use denominator. You want to use tenths, hundreds, thousands to make sure they know their place value. So now I'm going to see, can I count by 58 to get to 100? No. But they're both even, so I know I can divide by 2. So basically, I can find half of 58 and half of 100 to simplify it. So now we're going to go ahead and divide 58. There we go. We're going to divide 58 divided by 2 first. So what's half of 58? And you can have the students divide this out on the side, or some students are going to know how to find halves of numbers, so they'll know exactly how to do this. So half of 58 is 29, and then we're going to do what's half of 100, and we know half of 100, you should know, is 50. So now we have our simplified fraction, and then we need to write our therefore statements to show that all forms are equivalent. So we have 29 50ths, which is equivalent to 58 hundredths. Make sure you're using hundreds. Use the vocabulary with the students, because these are the words they will see when they're tested on it. And then we also know that that's also equivalent to 58%. So make sure that each time the students are writing their therefore statement so they can see that all of 3 forms are equivalent. They are the same. They represent the same amount that's on the hundreds grid. Okay, so this time they gave us the percent first. And we know with the percent, that's how many should be shaded in out of 100. So since they gave us the percent, I know I need to shade in 85 of them. So have the students count 8 across and then just shade it all in at one time. They need to know that each set is 10, 10, 20, 30, 40, 50. Make sure they know that and make it easy when they have to fill in the hundreds grid. So you fill that in, and then I know that I have 80. So now I need to shade in 5 more boxes just to get 85. So now I have my hundreds grid filled in. And now I should be able to write my decimal. And so then we'll have 85 hundredths at the end. So now, after I do my decimal, I know I can write my fraction. Now for my fraction, how many did we have shaded in? So I know my numerator is going to be what? 85. So I'm going to put 85 as my numerator. And then my denominator is out of how many? So 85 out of what? 85 out of the 100 that was there already. So 85 out of 100. And then I need to see if I can simplify. Can I count by 85 to get to 100? No. But they both end in a 5 and 0, so I can use 5, more than likely. So we're going to divide the top and the bottom by 5s. And you can have the students divide this on their side, or they can count by 5s until they get to 85 and see how many that would be. So if I count by 5s till I got to 85, that would be 17. And then how many 5s are in 100? How many times would I have to count by 5 to get to 100? And that's going to be 20. So now that I have that, I can write my therefore statements. So that means that 17 20ths is equivalent to 85 hundredths, which is also equivalent to 85%. So that shows all 3 of our forms and their equivalency. That hundreds grid represents all 17 20ths, 85 hundredths, and 85%. Okay, for our percent, it says 15% off. So we want to represent that 15%. So how many would I have to shade in for my hundreds grid? I need to shade in 15 of them. So I need a whole row. So that will give me 10. And then I will need to shade in 5 more after that. So you want to try to make these connections with the students in their brain. So eventually they're going to be able to tell you which fraction equals what decimal, which percent, especially when those big smart fractions come in. But you wanted to show them why, the why behind this happening. So for my decimal, I know I have 15 out of hundreds. So I have 15 hundredths. So I'm going to write 0.15. And then for the fraction, I have 15 out of 100. So my numerator is 15. And my denominator is going to be 100. And of course, we have to see, can we simplify that? Can we count by 15 to get to 100? No. But it ends in a 5 and 0. So I can probably divide by 5. So let's try that. We need to see how many 5s are in 15 and how many 5s are in 100. So if I count by 5s, 5, 10, 15, that means I have 3 of them. So I'll have 3 as my numerator. And then how many 5s are in 100? I have 20. And of course, you can divide this out. You can use long division. You can count by 5s, however the student chooses to do this. Now I'm going to write my therefore statement. My simplified fraction is 3/20. So I know that 3/20 is equivalent to 15 hundredths. And then that is equivalent to also 15%. They're all equivalent. They all represent the same amount. This time they did something different. They gave us the fraction first. So in order to get how many I should shade in, I'm going to have to divide. So the thing one of my partner teachers showed me is to turn the fraction on its right side. So if your students know your left from right, they'll turn it to their right side and they'll show them how they need to divide it. Because 3/4 is the same thing as 3 divided by 4. So you want to make sure they have the right dividend and the right divisor. So 3 is going to be your dividend and 4 will be the divisor. 3 divided by 4, and I'm going to add the decimal 0 because I know 4 can't go into 3. So how many times can 4 go into 30? 4 can go into 30 7 times. And then I'm going to write down 4 times 7, which is 28, and subtract that. And 30 minus 28 is 2. But this, when we're trying to find the decimal, you don't want a remainder. So then we're going to add another 0 and carry it down by the 2, which will give us 20. Now, I need to know how many 4s are in 20. I can count by 4 until I got to 20, which will be 5 times. So then I put the 5 above that 0, and then 4 times 5 is going to be 20. And then I subtract to see if I will have a remainder. And when I subtract that, 20 minus 20 is 0. So now I'm going to take that decimal and it shoots right back to the top of the house. And that means I have 75 hundredths. So I have the fraction 3/4, and I know that the decimal is going to be 75 hundredths. So I'm going to write that in decimal form. And I also know that if it's 75 hundredths, that's 75 out of 100, I can shade in 75 of those blocks to represent that fraction 3/4. So have the students count 7 over and then fill in all the way down. We need 70 first. And once they have that filled in, then we just need 5 extra ones to represent 75 hundredths. And at this point in the lesson, they will get what's going on. And they should know how to fill in 100 grids because they should have learned this before 6th grade or whatever grade that you're teaching this, depending on your state. So now I have 75, and I know that percents are out of 100, so I have 75%. And then I'm going to write my therefore statement. And a lot of kids will start to notice that the decimal and the percent look very similar. And they will know how to write those without having to connect it to anything else. So I know that 3/4 is equivalent to 75 hundredths, which is also equivalent to 75%. Okay, so this one's a little different. They gave us a fraction model, and we have to find a fraction. So I see that I have 8 pieces, so that's my denominator. And then I have 1 colored in, which is going to be my numerator. So my numerator is 1. And now I want to take this fraction, turn it on its right side, and divide. So you can have the students literally take their paper and turn the paper to the right, and it will do the same thing that I'm doing right now on the screen. And so then I can write my division problem out, which is 1 divided by 8. 8 is the divisor and 1 is the dividend. And the dividend goes inside the house. So can 8 go into 1? Nope. So I'm going to add a 0 at the top. And then under the house, I'm going to add a decimal and a 0. That's going to give me 10. If I ignore the decimal, it's like 10. So how many 8s are in 10? There's 1. So 8 times 1 is 8. And then we're going to subtract. I'm just following the normal steps of long division. And 10 minus 8 is 2. And we don't want a remainder, so we need to add another 0, bring it down, and that's going to give us 20. Then the students have to figure out how many times can I count by 8 to get closest to 20 as possible. And that's going to be 2 times because 8 times 2 is 16. So we need to do 8 times 2, we'll put 16 under 20, and then we're going to subtract that. And 20 minus 16 is 4. We still have another remainder. So now we're going to add another 0. Now there will be fractions you divide and you have remainders, and that will give you a repeating decimal. First, you want to give them a terminating decimal when they first start practicing this. So now we have 40. And now how many 8s are in 40? We know that there's 5 8s in 40. And then 8 times 5 is 40. And we're going to go ahead and put that under 40 and subtract that to get 0. And the only thing we have to do now is to get the decimal and let it jump back to the top in between the 0 and the 1. And it's going to give us our decimal for 1/8. And 1/8 is 125 thousandths. So right now, 125 thousandths. Now we're trying to find the decimal to the percent. And I'm going to show you a way that the students can easily figure this out. They're going to write down the decimal, and you could either multiply this by 100. You can have the students multiply it out by 100, get the answer for the percent, or you can show them this. If you multiply by 10, you move the decimal one time. Multiply by 100, you move it twice to the right. And that will give you a percent. Now, this is if the students understand that moving the decimal to the right one time is multiplying by 10. They need to have that understanding before you show them to move the decimal, because they need to know why. So that gives us 12.5%. So now, all we have to do is fill in our 100 charts. We need to fill in 12.5. So we need a whole row filled in. Then we're going to fill in 2 more. And then I'm going to zoom in a little bit to show you how I fill in the half. I use a diagonal line to fill in the half. The students may cut the box in half, but we only need half of one of those boxes because we have 12.5%. And then now the student can write their fourth statement. Our fraction was 1/8. So we know, and this is one of our benchmark fractions, and the students will start realizing that 1/8 is 0.125 and 12.5%. They'll start seeing that pattern and just memorizing it. But 1/8 is equivalent to 125 thousandths, which is equivalent to 12.5%. They're all equal. Okay, so remember, with the fractions, if you're trying to find a decimal, turn that fraction on its right side and then divide it, and that will give you your decimal. When writing decimals, make sure you use the place value and that your number ends in the correct place. Also, that percents are per 100. So if you have a hundreds grid and it's filled in, how many of that is filled in out of 100? All 3 forms represent the same value. So if I have 1/8, 125 thousandths, and 12.5%, they're all equal to the same value. By using the hundreds grid and connecting everything back to the hundreds grid, the student now understands the why behind finding the decimal, finding the percent, and finding the fraction. Thank you again for coming to class today. I hope this video will be helpful to you as you teach your students how to convert between fractions, decimal, and percents. Please give this video a thumbs up, share with the teacher that it may help, and leave us a comment below. Are there some other topics that you would like me to cover? Do you use any of these strategies when you're teaching your students how to convert from fraction, decimals, to percent? Well, you already know. Until next time, peace out.